In this video we're going to look at angles and quadrilaterals. Here's an example of a quadrilateral, a four-sided shape, and what I've done is I've marked in the four angles all with a green arc to show that they are the angles that we're going to look at. I'm not going to rip out the angles and put them sort of make them either the points. I'm just going to rip out the four angles. So there's one of the angles. There's another one of the angles. There's another one. And there's another one. So we've got our four angles. What I'm going to do is I'm just going to put them together. As you can see, the four angles meet at a point. So they, as you can see, if I sort of put them all together, it's a bit fiddly. Notice they meet at a point, so they make 360 degrees. Therefore, the angles in a quadrilateral add up to 360 degrees. So I've just demonstrated it for one quadrilateral. You could do it for different ones and see and check that's the case, or even just measure the four angles and add them up. But the four angles in a quadrilateral always add to 360 degrees. Typical example obviously is a square. You've got your four 90-degree angles. 490 degrees add up to 360. So let's take a look at some examples. Okay, so here you've got a typical exam question. You've got ABCD is a quadrilateral, and it's drawn a picture of it, and you've marked in three of the angles: 80 degrees, 55 degrees, and 120 degrees. And the angle at the point A, or little a, is unknown, it's little a. Okay, and you've got to work out the angle. So as you know, the angles add up to 360. This one plus this one plus this one plus this one will be 360. So we're going to add up the angles that they give us. Okay, so we're going to do 120 plus 80 plus 55. When you add those together, you get 255. So we're going to do 360, take away our 255, and you get 105 degrees. So to find a missing angle in a quadrilateral, you add up the angles that they give you. There'll be typically three of them, and then you take it away from 360. If they ever have a right angle, just write 90 degrees beside the little square and then do it the same way. Okay, here's another type of question. It says, explain why the sum of the interior angles of any quadrilateral is 360 degrees. They've drawn a quadrilateral for you on the page, and what I've done is I've just drawn a ruler, joined up using a ruler two of the opposite points. As you can see, you've got two triangles. And you know that the angles in a triangle add up to 180. So this angle, and this angle add up to 180. And this angle, and this angle add up to 180. So that way you can sort of explain that because you can split a quadrilateral into two triangles, that the angles in each triangle would be 180. Therefore, the angles in the quadrilateral would add up to 360. Okay, we're now going to look at some special quadrilaterals. So here's a parallelogram. I'm just going to mark on the parallel side. So the top is parallel to the bottom, and the two sides are also parallel to each other. Now, in a parallelogram, you have got two sets of parallel lines. Therefore, you're going to have co-interior angles. For instance, this angle and this angle will add to 180. Also, this angle and this angle will add to 180. But also, you've got another pair of co-interior, or another two set pairs of co-interior angles. So this one and this one add to 180, this one and this one add to 180, this one and this one add to 180, and this one and this one add to 180. So in a parallelogram, the adjacent angles add to 180 degrees. So for instance, if this was 60 degrees, this one here, then this one here would be 120 degrees because they are co-interior, because you've got your U shape. Also, this one will be 180 because these ones here you've got, again, your co-interior angles. Because again, you've got another two set parallel lines, and then these would be the co-interior angles. Also, this one and this one would be co-interior because, as you can see, you've got your U-shape there, or like an N-shape, and that would be 60 degrees. So the things would be that the adjacent angles always add to 180, and then also, I suppose, from that is that the opposite ones will be the same as each other. So if this is 60, this is 60. If this is 120, this is 120. So that's the special angles, that's the angle properties of a parallelogram. In a kite, there's one pair of equal angles. The equal angles are on either side. Also, if you consider the line of symmetry, you'll see there then why they would be the same size. Okay, remember kites get a line of symmetry down the middle, so therefore the angles on either side would be the same as each other. Okay, the angles on a trapezium, because you've got you've got a pair of parallel lines, okay, or two parallel lines, or a pair of parallel lines, you're going to have some co-interior angles. These two angles here will be co-interior, and these two angles here will be co-interior. That means that these two will add up to 180, and these two will add up to 180. Therefore, if this one was 60, this angle up here would be 120 degrees. And if this one was 130, because again these are co-interior, this one down here would be 50 degrees. So again, because it's a quadrilateral, all four angles add up to 360, and that whenever you've got your parallel lines, that the ones on the same side will be co-interior. Okay, now we're going to look at a rhombus. A rhombus, all four sides are the same length, and it's got two pairs of equal angles, so the opposite angles are equal to each other. So for instance, if this was 85 degrees, this angle down here would be 85 degrees. You can actually work out then what the other angles would be, because you know the four angles will add up to 360. If you add these two together, you get 170. Take it away from 360, that leaves you with 190, and then half that then would be 95 degrees and 95 degrees. So really in a rhombus, if you're given one angle, you can work out all four of the angles. So the main thing is that the opposite angles are the same as each other. Again, it's sort of because all four sides are the same length, but also suppose because they are parallel, you've got two pairs of parallel lines. Again, a bit like a parallelogram, the opposite angles will be equal to each other.